Good day everyone. Today's video is about solving other sequence. First, we need to consider the idea of inductive reasoning. Inductive reasoning, it is a reasoning that is based on patterns you observe. Basically, you're going to gather all the information that is very helpful for you to arrive with a conclusion. It means it will follow the specific to general procedure. A conclusion you reach using inductive reasoning is called a conjecture. And eventually, you're going to examine several specific situations to arrive at a conjecture, which is called as inductive reasoning. So, let us apply the idea of inductive reasoning in this problem number 1. What is the 35th term of the given sequence 3, 6, 11, 18, 27, 38, 51? The same procedure, we're going to write the problem in this way. And a sub 1 will be the 3 and the nth term will be the 35th. Now, the same procedure, we're going to bring down a sub n because we are looking for the formula. And a sub n has a sub 1, 2, 3, and 4. Then let's do the labeling. So a sub 1 is 3, 6, 11, 18 respectively. Put equals here. You don't know when to start, no worries at all. Just put n above that are 1, 2, 3, 4. Then since we are doing the multiplication concept, now let's go further in this place. And factor of 2 is 2 times 1. We can also use closer to 2 as 3, 4, and so on. Now let's try to use 3. 1 times 3 is 3, okay. 2 times 3 is 6. 3 times 3 is 9. And 4 times 3 is 12. Then after that evaluation, you will able to find that times 3, it's not applicable since in this case, we already equate the product as 3 and 6 for the first column. Rather, we're going to use the 2 here, and then 1 times 2 is 2, then probably you're going to add it by 1. 2 times 2 is 4, the same. 6, that is 5, and 8, that is 10. Evaluate, so after that, we have now n times 2 plus. Here, it's not consistent yet, so let's go with the second procedure. N times 2 can be written as 2n. The same this process, plus, 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 plus. So it means you just simply copy. Then, after that, you put n. Because you don't know when to start, n has 1, 2, 3, 4 respectively. After that, subtract all n by 1. Okay, minus 1, minus 1, minus 1, minus 1. And then after that, evaluate. Do the evaluation. 1 minus 1 is 0, so you probably add it to 1 to make it 1. 2 minus 1 is 0 is 1, add to 1 to make it 2, right? 3 minus 1 is 2, but adding by 3 is not 5. Okay, so 4 minus 1 is 3, adding by 1 is not 10, but rather you're going to add by 7. So after evaluation, okay, let's do the squaring. Okay, 1 minus 1 is 0 square 0, then probably add by 1 to get it. 2 minus 1 is 1, square is 1, probably you're going to add by 1 to make it 2. 3 minus 1 is 2, square it, 4, plus 1, 5. 4 minus 1 is 3, square it, 9, plus 1 is 10. So, you, after you square, you find out that it will give this column. And in short, we're going to square these rows, and then after that, you're going to add by 1. Therefore, 2n plus all of these are n minus 1 square plus 1 will be our formula. Again, let us just try to verify if our answer is right or wrong. A sub 2, a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, let's say a sub 6. Okay, the expected term for the sixth term is 38. So a sub 6, using this formula, substitution, 2 times 6 plus 6 minus 1 square plus 1. And this is 12, and this is 5 square plus 1. Okay, this is 12. 5 times 5 is 25 plus 1. And add it at once, 12, 25 is 37 plus 1 is 38. Then you got it right here. Therefore, you can now solve for our main problem as the 35th term. Using the formula, substitutions, 2 times 35 plus 35 minus 1 square plus 1 equals 70, plus we have 34 square plus 1. Using your calculator, okay, 70 plus 34 itself, so 1156 plus 1. Okay, count it as ones. Okay, the answer is 1227. So this is how you solve problem using the multiplication concept. What is the 40th term of the given sequence? 5, 9, 15, 23, 33, 45, 59. The same process. You're going to write the problem this way. 5, 9, 15, 23, 33, 45, 59. And we're so concerned with the 45th term of this sequence. Then common ratio, it can be, but common different is possible. This is 4. And we have here, this is 6, 8, 10, 12, 14, and so on. Let's go further. This is 2, 2, 2, and 2. It means that this sequence has a formula. How we're going to start? Don't worry, we're solving for the a sub n, since a sub 1 is 5 and the n term is 40. So we know a sub n means a sub 1, a sub 2, 3, and 4. And we have numbers as 5, 9, 15, 23 respectively, then equal. Okay, we're going to use another way, addition concept. So don't worry, put n here. Okay, you know, put n means 1, 2, 3, 4. Addition plus plus plus. What is the number to be added to 1 to make it 5? Obviously, it should be 4, and you're going to add it to the rest of the rows. 2 plus 4 is not 9 but 6. You need to add 3, 7, 8. 8, so this is 15. Obviously, it should be 0. Therefore, we have n plus 4. Plus, not consistent, so we're going to do the next procedure. Focus your eyes in this column. Then, copy. We have n plus 4 plus. Okay. Then after this is you need only to put the n. No worries at all. Just n 1, 2, 3, 4. Then after that, subtract to 1 or subtract by 1. Minus 1. Okay, then do the evaluation. 1 minus 1 is 0, okay. 2 minus 1 is 1, not 3. 3 minus 1 is 2, not 8. 4 minus 1 is 3 times, or it not be 15, but rather we're going to add it by 12. So after evaluation, try to square it. So squaring 1 minus 1 square, okay, is 0 square is still 0. You got right. This is square 1, that's 3. So probably you're going to multiply 3. 3 minus 1 is 2 square 4. Probably you're going to multiply it by 2. 4 minus 1 is 3. So square 9. Then multiplication is not possible, but adding 6. Therefore, squaring is not possible for this observation x. Then after that, let's put another n here. So n, we have 1, 2, 3, 4. 1 minus 1, 0 times 1 is 0. Okay. 2 minus 1 is 1 times 2. It's not 3. 3 minus 1 is 2 times 3 is not 8. 4 minus 1, 3 times 4 is not 12. But try to evaluate. 4 minus 1 is 3. To make it 15, you're going to multiply it by 5. What will you do to 4 to make it 5? You're going to add by 1. Now, the same process. 3 minus 1 is 2. To make it 8, you're going to multiply by 4. What you're going to do with 3? You need to 1. 2 minus 1 is 1 times, to make it 3, plus 1. And so it follows consistency, and therefore we have now the formula as n plus 4 plus all of these are n minus 1 and all of these are n plus 1 will be our formula. Now let us again verify. On the given sequence, let's say 2, 3, 4, 5. We want to verify on the fifth term. So we're going to verify a to the fifth term using the formula substitution. 5 plus, we have 4 plus n is 5 minus 1. 5 plus 1 is our formula. So this is 9 plus this is 4 times 6. And our fifth term is 33. So 9 plus this is 24 and this is 33. Therefore, our formula is correct. In short, we can now solve for the problem of the 40th term as a to the 40th term is 40 plus 4 plus 40 minus 1, 40 plus 1 follows 44 plus 39 times 41, and we have 44 plus 39 times 41 is 1599. Then equals, add to 44, we have 1643. That will be our A sub 40. That is how we apply the addition concept for this problem number 2.